This question is about an experiment to determine the solubility of strontium hydroxide in water at 20 degrees C. Strontium hydroxide is added to approximately 1 decimetre cubed of distilled water in a stoppered flask. The mixture is kept at 20 degrees C. Every day the mixture is checked. If no more solid is present in the flask, more solid sodium strontium hydroxide is added. On the day when no more solid needs to be added, the flask is opened and the mixture is filtered into another flask and stoppered. 25 centimetre sample of the fill tray is transferred to a conical flask with a pipette and a few drops of indicator is added. The sample is titrated with 0.1 molar hydrochloric acid, repeated several times with further samples. The results are shown in table 1 on page 8. Suggests why the solution is kept until no more solid needs to be added. So they're adding the solid, and then if all the solids dissolving, they're adding more solid, and they're keeping on doing that until they don't need to add any more solid, because the maximum amount of solid has dissolved. They've made sure that their solution is saturated. As the solution contains the maximum amount. Suggests why it is important to remove the undissolved strontium hydroxide before the titration. Well, if you don't remove it, as you add hydrochloric acid, it will react with the strontium hydroxide in solution, but also the solid strontium hydroxide, and your titer value, you would need more HCl. So the titer value of HCl would be larger as HCl reacts with the undissolved strontium hydroxide. After the filtration, the solution is stored in a stoppered flask. Suggest a reason for stoppering the flask. Well, there might be two reasons. We want to prevent evaporation, which would change the volume of water. And also, strontium hydroxide is an alkali, so we might want to prevent reaction with the acidic gas in air, which is CO2. So both of those things are possible reasons to stopper that flask. The diagrams in figure 2 show the part of a pipette with the graduation line. Which diagram identifies the pipette that is correctly filled? So the meniscus that looks like a contact lens needs to sit on the line, and so the answer is C. Solubility can be quoted as grams per 100 centimetres cubed of solution. Table 1 shows the results of the titrations between strontium hydroxide and hydrochloric acid. These can be used to determine the solubility, the number of grams per 100 centimetres cubed of strontium hydroxide. Give an equation for the reaction between strontium hydroxide and hydrochloric acid, and use the results in table 1 to calculate the mean titer. Use the mean titer to calculate the solubility of strontium hydroxide in grams per 100 centimetres cubed at 20 degrees C. So the first thing we're going to do is write an equation between strontium in group 2, hydroxide, and hydrochloric acid. So we're going to make strontium chloride, group 2, so 2 chloride ions, and water. So to balance that, we're going to need 2 HCl's and 2 H2O's. We're going to have a look to find our mean titer. So we kept titrating until we got concordant results. So our final result is concordant with our first result. So we want to average 32.40 and 32.45. So that comes to 32.425 or 32.43 centimetres cubed. So if we go back and we read quite a few pages back, the concentration of the hydrochloric acid, so we now have the volume as 32.425 and the concentration as 0.1, and that was when it reacted with 25 centimetres cubed. So the number of moles of hydrochloric acid, 32.425 into decimeters cubed times by the concentration, so 3.2425 times 10 to the minus 3 moles. Use the ratio from the balanced equation to find the number of moles of strontium hydroxide, so divide by 2. So you do that on your calculator. And you get 1.62125 times 10 to the minus 3 moles. That is in our titration, which was in 25 centimetres cubed. Now it says that the solubility is in grams in 100 centimetres cubed. So let's scale up and find out how many moles are in 100 centimetres cubed. So how many 25s are in 100? Well, it's 4. So I'm going to times by that scale up factor and get 6.485 times 10 to the minus 3 moles. And then this wants the grams, so we're going to do mass is Mr. Moles. So I'm adding up strontium hydroxide, and if I add up strontium hydroxide, I get 121.6. I'm going to times that by my moles, and I'm going to get 0.788576 grams. I'm just going to check it didn't say significant figures. No, just said give the solubility, so 0.79 grams per 100 centimetres cubed.